All right, guys, today we're going to talk about reading codon charts. This is basically the way that we can figure out when we go from DNA, what does that DNA code for? And so you have DNA, and remember that DNA copies to mRNA. And the way that you can tell the difference between DNA has 4 bases. It has G, A, T, and C. And mRNA does not have thymine, okay? It does not have T's. So it is G, A, U, or C. So we're replacing right here we're replacing this T with a U. All right, that is RNA has uracil, where DNA has thymine. Okay, so this is very, very important that you understand that these are the 4 nucleic acids that you find in DNA, where these are the 4 nucleic acids that you find in RNA. So when we copy DNA to RNA, you will end up having G's. Okay, here we have DNA, and DNA's G will bond with RNA's C, okay, because G's always combine with C's, right? And I'm going to scroll this up a little bit if you don't mind. Okay, so then we have in DNA, we have G's, and in RNA, we have C. So every time we have a C in DNA, it is going to bond with a G in RNA. Then we have T's in DNA, and RNA has adenine, which will combine with that thymine. The only change here, and this is a big change, is adenine doesn't have thymine to attach to, so it will attach to uracil. So this is one of the big differences between DNA copying itself and DNA copying to RNA. So if you ever see a U, if you see a code and that code looks like this, let's take a look. I'm going to show you a code. Okay, and we see GAT, CCCU, TCCTA, TCCG. Then we know that this code has to be DNA. How do we know? Okay. How do we know this? Because it has thymine. Okay. Now, if we take a look at another code, we have A, U, G, C, C, U, G, G, A. All right, so we have another code. We can look at this code and tell that it is RNA. And how do we know? Because it has uracil in it. Okay. This becomes very important because we're about to decode these pieces of DNA. And I'm going to give you a random piece of DNA. And I'll make this a little bigger so that we can see it. Okay. And I'm going to give you over here a random piece of DNA code. So DNA, I'm going to give you the code UA. Can't be U because it's DNA. So it is GTCAAGACCT. All right, and one sec. All right, I want to add one more so that I have a multiple of 3. We're going to talk about Y in a second. Now, remember that all DNA is broken up into pieces of 3 for copying purposes, and so we're going to just put spaces between there. Now, when I come down here, when that DNA copies into RNA, how can we make that copy? Well, this G is going to become a C. This T is going to become an A. This, and I'm going C to G to C, T to A. This C will then become a G. Okay. This A will become a T. No, your RNA doesn't have a T, so this A becomes a U. Okay, U, U, U. This is A is U, U, U. Then G here becomes a C. A bonds with U, and C bonds with G. Okay. Now I'm going to let you do these last three on your own. See where it's highlighted up here? I'm going to let you do these last three on your own. I would like for you to please pause the video at this point. Okay, we're going to pause the video at this point so that you can complete this. C bonds with what? T bonds with what? And A bonds with what? All right. Everybody should have what C, T, and A becomes. So C becomes G. Follow along with me here. T becomes A, and A should become U. This is just decoding our DNA. So I would like for you to take a look. This is our RNA code. This is the copy of the DNA code. So the original DNA, this would be found in the nucleus. Okay. Just a second. My setup is all there. Okay, so this would be found in the nucleus, and this RNA would be made in the nucleus, but then travel to the ribosome. Okay, so now that we have this code, how do we know what amino acids this code would make? So what we're going to do is we're going to highlight this. Okay, and now we come to what we call the mRNA codon chart. And you'll notice, looking down the side here and looking across the top, that this does not decode DNA. It decodes only RNA. So that's why we had to code our DNA into RNA first. So you code DNA to RNA, and then you use this chart to decode the RNA into amino acids. So that's what our ultimate goal here is to decode these into amino acids. So we need to go from RNA to amino acids, and that's what this codon chart does. You'll notice this codon chart takes RNA and then turns it into the amino acids that we need to get out of this. So what I'm going to show you how to do is read this codon chart, because this codon chart is kind of the decoder ring of all biology. So it will actually tell us what that DNA originally was coding for. So over here on the right, we have our RNA code that we got from our DNA template, our DNA original. Our RNA copy was CAG-UUU, CUG, GAU. And this is found in the ribosome. And this is all happening in the ribosome. So I want to come over here, and I'm going to show you that decoding this is actually quite simple. You take your 3-letter code, and that's over here. Our 3-letter code is called a codon. So this CAG portion right here is called a codon. It's a little fragment of code. And you come over here to our chart, and you'll notice that this first letter is C. So what we're going to do is we're going to only pay attention to the stuff in this row, this C row, okay? And so our answer has to be somewhere in that row. Then the next letter is up here on the top. So you go first letter on the left-hand side, second letter across the top, and our second letter here is A. So if we highlight our A column here, you will notice here in the center, we end up with a block where they overlap, okay? And then you come over here to the right-hand side, and that is going to be your third letter. Let me change colors here in just a sec. And what happens is you take your third letter, and of course your third letter here is G, and we are going to read across here, and that means that GLN is this amino acid that will be attached to this ribosome. GLN. Okay. Right? So GLN is our amino acid, and we have decoded this fragment of RNA. Then I'm going to encourage you to decode the UUU fragment, the CUG fragment, and the GAU fragment. Now, before we do that, I am going to show you a second type of codon chart. And what I'm going to have you do is flip your codon chart over to the other side of the page, and we will talk about. Okay, and here we have our second codon chart, and we're going to copy our little RNA fragment again so that we know what we're decoding. Now, this codon chart works a little differently. It doesn't have the left, the top, and the right. For this codon chart, you're actually going to read from the center to the outside. So if I were decoding UUU, this fragment over here, for example, if we were decoding the UUU fragment, okay, so right here, then we come over here and we start from the center, and we say, okay, the first letter is U, the second letter is U, and the third letter is U. So that means that our amino acid would be phenylalanine, okay? So you would put P H E. So that would be phenylalanine, okay? So this is just another type of codon chart, and you read it a little differently. Some people prefer this type, some people prefer the other type. It's really all a matter of taste and what kind of chart you have available. We don't know what kind of chart is going to be available on the end of course exam for biology, but we want to make sure that you're able to read all of the chart types. So I'm going to give you a little time to practice, and I'm going to link a couple of other videos to go through this process again in case you didn't understand the way that I described it. I'm also going to give you some RNA fragments to practice this decoding so that you can practice DNA to RNA and then RNA to the amino acid, okay? If you have any questions, please feel free. I'm leaving my contact information. I will be checking my email while I'm out. This decoding will not be on your exam. However, you do need to understand the differences between RNA and DNA. And so I'm going to come back over here and just give you a real quick rundown in the last couple of minutes of what is the difference between RNA and DNA. So to start off, of course, DNA, okay, the D stands for deoxyribose, which is the different sugar that DNA has, okay? Also, DNA has a D for double helix, and DNA has thymine, okay, as a nitrogen base. All right. Conversely, meaning the opposite, is RNA. RNA has ribose sugar, and RNA has a single strand helix. It's not a double helix. And RNA has uracil as a nitrogen base. Okay. So you do need to know those basic differences for your test, and I will be posting a quick study guide and study sheet on the website. So please visit the website, study for your test on Friday, and if you have any questions, please feel free to contact me using the contact methods on the website. I will not be checking email after about 8 o'clock at night, so email me during the afternoon and I will answer as soon as I am available, as long as my cell phone charge holds out, okay? I will see you guys later. Have a fantastic time while I'm gone.